We can start in 2 minutes.
2 minutes, yes. I will share my screen just quickly if you can confirm if it's visible.
Yes.
Yes. Okay, this is great. Okay. Okay, guys, I'm starting it. Let's wait for people to join. Yes, so people have started to come inside. It's great. That's fantastic. People have started to join in. We will just give it another 1 or 2 minutes and then we will
Right.
start. Okay, so we have a lot of guests saying hello. Hello, Hala. How are you? Hi, Ashok. Hi, Vilas. Rajesh. Wojciech. Nice to see you guys. Okay, so I think we've got fairly good number of people joining in, and we should start right away.
Yes, we can. Let's start now.
Uh, are you able to see my screen now?
Yes.
Okay, fantastic. A very good afternoon from Dubai to all of you. Welcome to episode 4 of the Technal Facade webinar series. I'm super excited to welcome you all on this very important topic of life safety design for facades. I'm excited to welcome people from all over the world, from Europe, from Middle East, from India, from Southeast Asia. A very, very good afternoon and greetings to all of you wherever you are today. Today, we've got a fantastic panel of experts with us on board to discuss on this very important topic of life safety design for facades. And without further ado, I would like to start today's webinar open with a small thank you note to our wonderful frontline workers who have been doing some exceptional work during this lockdown period. We salute you for all your relentless efforts and work you've been doing for us to be safe. So thank you so much for all the frontline workers and staff who've been giving out their best efforts for us today. So before I start off today's webinar, I would like to give a quick introduction about Technal for people who don't know Technal. So Technal belongs to the Hydro brand. Hydro is one of the world's largest and probably the only 360-degree aluminum company. We have our own bauxite mines. We produce our own alumina. We produce our own energy from hydroelectric power. We have our own aluminum refinery. We produce our own primary metal. We have our own rolled products division, and we have the extrusion business. And under the extrusion business, That's where we have the building systems brand. And also in addition to this, we have our own extrusion plants and precision tubing for industrial applications. So under the building systems brand, we are present as Technal, which is one of the most well-known architectural aluminum system brand. We are celebrating our 60th year this year. We are present in more than 70 countries in 5 continents. We'd like to call ourselves as leaders in aluminum glazing systems. Architects like to call us our partner for the most complicated projects which they have. And we pride ourselves in innovation and design expertise. In terms of solutions, we have a wide range of architectural aluminum solutions, from sliding systems to windows, doors, and facades. And in addition to this, we also have special solutions for building safety, for fire protection, for windows, doors, and facades, for bullet and burglar resistance, sliders, windows, and doors, both of which you will hear a little bit later today, but from my colleagues. We have shop and office internal partitions. And in addition to this, we have pergolas, verandas, solar protections, railings, gates, and fences. With that, I would like to open today's discussion on facades for high-rise buildings. Before I start, just to give you a quick housekeeping announcement. We have 2 ways of interacting with our panelists. If you face any technical difficulties or any challenges during the webinar, please use the chat box to raise anything to us. If you have a specific question you want to address to the speakers and panelists, please use the Q&A section. That will be very useful for us to see your questions and bring it up to the panel as well. So feel free to use both these tools today. During the course of the webinar, there will be a lot of polls. So feel free to give your feedback and your responses. That would help us to keep this conversation very interactive. Okay, so coming a little bit back to our topic today, we want to talk a little bit about safety and why the premises behind safety and why it is so important today. We spend almost 90% of our time indoors, and this is especially today in a situation where we have the pandemic situation. We are spending almost every hour of the day inside buildings. Previously, the pre-pandemic situation, you would have various buildings we spend time at in schools, malls, in offices. But today, I think the post-pandemic shift is more towards working from home. And what is important is to understand how safe are the buildings we are working and living from. And to address that today, we have a very fantastic panel who bring with them more than 100 years of experience in safety for facades and for buildings. So with that, I would like to invite our first speakers for today's webinar. Let me introduce you our first speaker. We have with us Sandy Dwight, who is the CEO of Thomas Wheelwright International Consultants. Sandy joined Thomas Wheelwright Consultants in 1997, and today she's the partner from 2002. She's been a pivotal part of the company's success, and for many years she was heading the facade consulting department. Over the last 2 decades, she has been a part of very large number of projects as the company provided the key tools to the building envelope industry to deliver better quality and safety. Along with her, we also have Abhishek Chabra, who is a market development manager at Thomas Wheelwright International Consultants. Abhishek joined Thomas Wheelwright in 2013 and has been the driving force behind the expansion of the fire compliance activities into new markets. He's an engineer with a postgraduate diploma in finance, and Abhishek brings with him valuable experience from other larger testing, inspection, and certification companies. He has over 18 years of experience, and he would share his wealth of knowledge today on this topic as well. So without further ado, I now invite Sandy and Abhishek to take over. Sandy and Abhishek, the floor is digitally yours.
Thank you. Thanks, Arvind. Okay, I hope you all can see my presentation.
Yes, it's visible.
Okay, thank you very much. We are really glad to be part of the Technal webinar series, and this session in particular that concentrates on life safety design for facades. We are also going to highlight a little bit the current situation with COVID-19 work restrictions, and we will talk about the importance of testing in general and the importance of testing during these times, what can go wrong with the current setup, the current change in building use and its impact on facades, and some questions to consider post-COVID. We are hoping, of course, that all such restrictions will clear up and we will go back to our normal lives, but at the same time, we would like to learn from this experience. So I will start with a brief introduction. A lot of you might already know us. We have started 25 years ago with facade consulting and curtain wall testing. This video is from our laboratory in Jebel Ali, showing some of curtain wall testing services. We also have expanded into testing of material for reaction to fire lately. And we are testing fire-rated elements. And recently we have also added the capacity to test full systems with their full components for fire propagation. We are very proud to be accredited by UCAS as a test laboratory, as a certification body, and as an inspection body. And we would like to think of ourselves as a one-stop shop for all services related to facade compliance. So why is it critical to design a facade? So facades in general are representations of the buildings, similar to a cover represents a book, for example. And for us engineers, we like to judge a book by its cover. So if you see a facade, it might tell you what the building use is, what is the age of the building, is it old or new, is it residential or office building. So much can be read about the building from the facade. This item is an expensive item. It is 10 to 15% of the construction package. And this is not the only critical part about it. It's not only its own price, it is also that it affects the function of the full building. Since you use details or elements that are repetitive and installed sequentially, any mistake can be a repetitive mistake which needs extensive fixing. We usually install from the ground up, and individual elements cannot be removed or replaced easily after this sequence is in progress. Wholesale replacement of a facade is very prohibitive. It is detrimental to the use of the building. You have to strip the facade from the top downwards and then start all over again and build a new one from the bottom upwards. So you can't use the building for a very long time. So our objective is to provide a safe facade that keeps the people in and keep the weather out, and also a facade that will last without major maintenance for the design life of the building, which is 25 to 50 years. In order to do so, we will need a teamwork process that includes all stakeholders on the project. So you will need a collaboration between project management, consultant, facade specialist, system designer, and contractor. The process itself, which is the verification and review process, starts with a proper description of the facade. So you should have proper design drawings, you should have the proper specification that explain what is the function of this element. After award, there will be a system review and then testing, which I'm going to describe in more details. Validation of the system through testing is very important. After that, we can go on with shop drawing review, factory monitoring, on-site testing, and site inspections. So each project is different, each project is unique, and each project has different performance requirements for facade. The weathering requirements is usually set in the specification, can be tested to ASTM, AMA, or CWCT, but ASTM is much more common in the Middle East area. There are also other aspects which should be specified relating to thermal expansion, thermal efficiency, and building movement. Lately, we have seen much more details related to classification of material, the fire classification, let's say. We have also a performance requirement for cladding systems and how they should behave under fire. And we also have specification related to perimeter fire stops. This follows each project, where it is located and what jurisdiction it should meet. As we said, testing is an important part of the validation process. And the first step to validate the design and the system is to have a laboratory test. So a mock-up that represents the system should be installed at the lab before installation at site, in order to understand everything about the system and make sure it meets the performance requirements. The shape, as you see in the photographs, can vary, and it should include all the critical parts of the system, and it should include specific elements related to the project. The largest mock-up that we have tested, for example, recently is 10 meters in width and 5 stories in height. So it depends on critical elements and how the system can be represented at the laboratory. The basic range of tests is highlighted in red. It is air infiltration, static water penetration, and structural load test. So this is the minimum that should be done on any project. Structural load structural load test is run at the design load and as a safety test at 1.5 design loads to check for deformation or breakages. Other tests are, of course, related to projects and can be specified at the discretion of the architect or the consultant. The basic tests revolve around fixing a mock-up, as you see here in the picture at the bottom left, to a support structure, a steel support structure, which represents the supports at site. After that, a lightweight chamber is built around the mock-up, and a difference in pressure is generated between this chamber and the exterior of the mock-up. Through the generation of this differential pressure, we assess for air infiltration, we find out the air infiltration rate, we check for leakage, and we check the deflection in the structural load test at design wind load, and we overstress the mock-up at 1.5 to check for breakages. In order to do all of this, all the components of the mock-up have to be exactly the same as what should be used at site, because any change can cause a change in the test result. These are the other discretionary tests that can be conducted as well. The most common is the dynamic water penetration test with the airplane engine representing wind and water sprinklers put on at the same time. Vertical and horizontal building movement can also be conducted by moving the supports that support the mock-up, and the cladding system should accommodate for main structure movement. We can also do thermal cycling, impact test, and restraint socket pull out to make sure that the full system works properly. The most important aspect of testing at the lab is to document the sample that we have tested properly through controlled dismantling. Those details are the details we should use later on when we are inspecting at site to make sure that we are checking the same components and that the same design is carried on during the other stages of the project. On-site chamber testing, where we bring the chamber, the test chamber, similar to the one in laboratory testing, to site. We can conduct air, water, and structural load. This is a water test conducted at site. This is a chamber, which we can construct behind the mock-up at site, and we can assess for air infiltration, water penetration, and structural load. Other tests are not possible at site because they might overstress the material which is already installed. There are other tests such as whole building air leakage tests and balustrade tests, and we find that these might be more relevant now during the COVID-19 lockdown, because the efficiency of the full facade has become more important to people because it impacts your energy bill. People pay for their energy bills themselves. They are spending much more time at home, and they need an efficient facade that is in a controllable environment so that they won't be paying for leakage. And this other photo is for a handrail test. Many people are spending time on balconies. Balconies should use the correct material, and they might be tested also for loading. And the critical part about balconies is not only the design of the balcony, it is also how people are using this balcony and whether they are using it correctly. Other tests, so the important part of facades as well is cladding systems. So the cladding system is also part of this facade, and we will talk now about fire testing of these systems. This is a bit more regulated, and it's a bit more lengthy process, and I would hand the mic over to Abhishek, who will describe it in further details.
Hello, everybody. Fire compliance is something that has been becoming more and more important in the last many years. And unlike many other products which can be batch produced in factories, the building envelope, the cladding system is often not only a custom designed system, but has several stakeholders involved. Countries, municipalities, jurisdictions, specification writers have been developing a lot of learning.
We can't hear you. Sorry. Yes.
Can you hear me now?
Much better now. Thank you.
Okay. Hi, everybody. I'm just going to quickly repeat what I said. Fire compliance is something that has been becoming very, very important in the recent times, specifically with all the fires happening. And unlike a standard system, which is probably manufactured in a factory, a facade or a building envelope system has several stakeholders who are designers, who are suppliers, installers, etc. Countries, jurisdictions, manufacturers have all been realizing several areas which were getting missed out in the past when facade systems were installed, facade systems were designed. There are three key learnings that have been coming out of these, and these three key learnings have been implemented by different countries, different jurisdictions in different ways, but the core remaining this, that it is important to know the reaction to fire properties of each and every element that could be potentially combustible. And it is critical to understand how to establish the traceability of materials that are coming on the site. The second and an equally critical part is to understand that when several materials come together to design a system, their cumulative and behavior is different than their behavior when the materials are tested or evaluated as it is. So a system requirement or a system behavior needs to be separately evaluated apart from the material behavior to be evaluated. And then obviously, and very, very critical, is that in designed and systems where several stakeholders are involved, it is important that there is a detailed and a thorough inspection done on the site to ensure that the right materials have come in place. In this slide, I am going to talk about how these aspects are regulated and viewed worldwide now. The risk assessment is done at the start of the material selection process, and now more and more the properties which are related to ignitability, combustibility, calorific value are independently assessed for different materials which will build up a facade system. The route of certification and listing is something that is being used more and more in many countries to ensure that the supply chain of materials supplied to the site is regulated, which means that there is a unique traceability number that can be looked up at the packaging or at the material received on the site. Just like if you turn around your laptop chargers, you would notice that there is a number, and the number leads you to where the product is manufactured. And for inspection bodies or contractors, they need to be aware that certification and listing provides these tools. The next step is, once the right material has been chosen to design a system based on its reaction to fire properties, the evolved property of the joint combined system is assessed. We all know that typically facade systems have hundreds of drawings, sometimes even thousands. And this is where the fire consultant, the facade specialist and contractor, either individually or together, arrive at some set of design details which are critical. These design details are mocked up in mock-up tests, which are typically fire propagation mock-up tests, and I will talk about them in the next slide. Passing of these tests give a very good idea for the contractors and the authorities that the design ideology to ensure that the fire does not propagate has been validated, and hence this leads to approval of the design. And then the last and very, very important critical step is the fact that these approved drawings need to be installed correctly at the construction site. You can see some of the images on your screen. These are images of inspections that we have done. And it's very unfortunate that somehow when the material does get installed on the site, it may not necessarily get installed the way we imagine the drawings to be perfect. So in the next slide, I'm going to briefly talk about the large-scale fire propagation tests, which are used in lots and lots of different jurisdictions, including the Middle East. Here you would see on the top right section of your screens that there is a two-chamber test setup. There is a chamber on the ground floor, as we call it. This is called the room burner. This test setup simulates a situation that if there is a fire inside a building and the fire then breaks out of a window, then how the environment and the fire can potentially attack the cladding or the building envelope. So if you see the video that is running on the left of your screen, you would notice that the window burner creates or tries to create what is called the leapfrog effect, which means that the fire breaking out of a window and attacking the whole facade system. This is the large-scale fire propagation mock-up test, an American standard, but used in many parts of the world. There is another test called the BS8414, which is also done in our lab and is a fairly popular large-scale fire propagation test. The same test rig is also used to conduct another test called the ASTM E2307, which, if you notice the image bottom in the center, this is an image of a missing perimeter fire stop, or probably a badly installed perimeter fire stop, because if you notice, you can see right through the gap. Now this gap where the perimeter fire stops have to come in are the critical element that ensure that if there is a fire on a given floor, the fire does not break on and propagate to the floor above. And so the same test rig is also used to validate the fire resistance of the perimeter fire stop. This is a quick and a brief overview of the fire tests related to building envelope materials. I will give the mic back to Sandy to continue her presentation.
Thank you, Abhishek. Okay, so why do we test? So each system and each project is different, and we have to go through a validation process. We have to check that it meets the performance, because this is not possible to do off drawings only. We have to understand the material behavior and the system behavior in case of fire, because we want to reduce the risk of the fire spreading very fast. And we want to contain the fire in order to manage it and put it off in time. So basically, we test in order to verify compliance to project, code, and regulation requirements. And because it is part of this verification process. In case we do not go through this process, many things can go wrong, such as water leaks, condensation, basically failures related to weather, or more severe failures related to public safety, such as glass fallout, or structural failure, or fire. So why is testing and verification more relevant now? So basically, we have all been, we are all working from home now, and many of us were pushed into a sudden shift of collaborating virtually. And this new form of collaboration needs input from everyone. I think that it is quite useful to have an expert eye that is trained to find discrepancies, to assist with reviews, and to raise points that might cause problems later on. So the collaborative verification and testing process that involves all stakeholders on the project needs to go through this thoroughly, and they need to assess any change that might happen to the system. With supply chains interruption and material not reaching the factory or site on time, people are looking into alternatives. Of course, a responsible system provider, a responsible contractor will come forward and say, I have this material that is late, I am proposing 2 alternatives, and the project team can assess these alternatives, because this is happening now all the time, and we are striving to find solutions. At the same time, not all of our manufacturing and installation is automated. So in case some people fall sick, we do not want to replace them with untrained ones. So many people have mitigated this by providing alternative teams who can work, who can replace other teams. Physical inspection at site has become very important, because you need to check that the material delivered at site is the same that was approved. And in case of changing any materials, we can assess the adequacy of alternatives. A facade specialist and the full team can sit together and discuss how to do saving without affecting quality, because compromising on quality today will cost much more in the future. And as part of the construction industry, I think that we have a responsibility, same as doctors, same as drivers, same as anybody else, to do a good job under these circumstances and to deliver a good product. Shifts in building use and how it's affecting facade. So more people are spending time in residential buildings, and this highlights actually the efficiency of facades. A more efficient facade means less expenditure on your energy bills. Balconies have been used much more recently, so more tests can be conducted for balconies, for loading, but also it is very important to highlight that the use of balcony is also important. We do not want to have any combustible materials thrown out as clutter on balconies, because this will pose a risk that might start a fire and cause problems or accidents. And also the behavior of the people. If I have not been like for 2 months in a restaurant to have a shisha, maybe I will have it on my balcony even if it's not allowed. And we have to also consider that people might block fire escapes by putting unwanted items on stairs, thinking that they might pick them up later, but this is a major problem because it will not be able to evacuate the building efficiently. So accidents and failures, they can happen. So for example, this recent fire in Sharjah was caused by a cigarette butt which was thrown from a higher story into a corridor. And we want to avoid such extremely high expenses by going through a proper process from the beginning. So I will leave you with some questions to consider post-COVID. We hope that this is only a temporary situation. Maybe it will propose creative process or a change in the work ethics or the change in the work setup. We don't know. So these are the questions that we might think about or research later on. And thank you all for listening. Thank you, Technal, for giving us this chance to participate with you. And I will give the mic now to Sami Zghaib and Arvind.
Thank you so much, Sandy, for your wonderful insight. I think you put it up very nicely, talking about the various testing framework methodologies. You also touched upon a very important topic of, in fact, it was Abhishek who brought this up in terms of the compliance process. Whilst you were speaking, I did a quick poll, and I would like to share the results with you. So in terms of our audience so far, we've have about 30% of our crowd is architects. We have 8% developers. We have 12% facade consultants. And we have main contractors, about 5%, and the facade contractors are 18%. And then I asked them the question about curtain wall testing, if they've witnessed tests. 53% of them said they have witnessed a test, which is great. And there's the remaining half who have not witnessed it yet. Mm-hmm. So I think it's pretty cool to go and check out Thomas Feldride whenever is the chance that arises for you. In terms of fire tests, we've seen that almost 77% have not yet seen a fire test. It's only 23% who have witnessed a fire test. And in terms of fire compliance tools, we asked a question if they're aware about the fire compliance tool for building envelope systems. 45% of them are partially aware. 23% of them, they are not aware and then 33% of them are aware. So I think more than 60% of people still need to learn more about fire compliance tools. And I think once again, you know where to go. If you want to know about this, feel free to reach out to Thomas Padrai. And then to add to what Sandy was talking about in summary is how would we react post-COVID and how we are feeling in this current situation. We threw a question about where are they currently working from? And 59% of them say that, yes, we are working from home, but this is a temporary situation. 25% of them feel, yeah, we all hope so. And then 25% of them feel that, well, this situation could be for a long period of time. And a very small percentage, about 15% of them have actually moved to their office spaces. So we hope that the situation is temporary, but whilst they're there in the house, I think you brought up some very interesting points about overcrowding in the balconies, keeping your emergency exits clear, because we don't know when emergency situation can strike. So thank you so much for your wonderful insights. There are a lot of questions pouring in for you as well, but we're going to keep that at the end so we can have a good common discussion. For now, I want to invite our next speaker, a dear colleague of ours, Mr. Sami Zagaib, who's the Technical Director for Asia in Hydro Building Systems. He's a civil engineer hailing from the reputed Lebanese University Faculty of Engineering. He has completed a specialization in structural design and engineering, and he has over 20 years of industry experience, and he's currently managing the technical department for the entire Asia region for hydro building systems. Without further ado, I would like to invite Mr. Sami. So Mr. Sami, the floor is digitally yours now.
Thank you, Arvind. Thank you for the introduction. First of all, I hope you are hearing me clearly. Hello for all the audience. I will share my screen. Hello to all the audience. I hope it is, as I said, beginning clear and you are able to see my screen clearly.
Yes, Sami, we can see your screen very clearly. Thank you.
Yeah, thank you, Arvind. I will provide a presentation which can provide a clear figure and explanation about the contribution from system supplier as Technal in Facade and contribution in safety and security. The main requirement in the building for safety so the main requirement for safety in the building to secure the protection, we have seen in the previous presentation in the lab test in Thomas Barrett presented by Sandy that the testing for the parameter for water tightness, air tightness, wind load pressure, these are deriving from parameters from the weather influence on the building facade. The building facade is the building envelope separating inside from outside, and it will be subject to more wind pressure. We can see the requirement of the structural performance as a requirement. That means to get a safe facade, it should be structurally safe with all the components, the structural member, the framing, the infill should be well fixed to avoid any things falling from the facade. In addition, the facade should be also the barrier between inside and outside to separate the heat and the cold. So we should feel more comfort when we are sitting behind the facade. Also, it should be also watertight against any rain. It should be also well airtight for smoke. These are the main weather requirement protection in the facade. In addition to that, in line with the subject of this webinar, if you're talking about security and safety, the fire propagation in the building is important, and it will be also one of the requirements. In addition to that, the enhanced force entry solution to provide a solution where we can get it more safe. And in some particular project and some sensitive project, there is some requirement for enhanced blast resistance. We have seen the recent period, unfortunately, a lot of terrorist attacks and more requirement for safety. And in addition to that, also there is some other requirements like noise, like designing material eco-friendly, recycled. All of this, while talking about this requirement, this is Technal taking in consideration this in the design of the components. And it will contribute also in the R&D to develop more and more solution, eco-friendly, to cover the change in the climate. We can see more pollution, more requirements to get our living place well comfort. And one of the points which I can add it also, the contribution also in providing the raw material used in the aluminum system, the aluminum by itself, by the group. We are providing also sustainable product, because the material for the production for the aluminum is consuming less energy and contributing in low carbon emissions. And this has been detailed in previous webinars about sustainability. It's also available in the YouTube web if you want also to get a look on it. And this also as a part of contribution. Passing to the product-wise offer by the group, by Technal, we are offering a wide range of doors and windows, sliding system, facade, sun shading, guardrails. And in this, we are also providing the solution, achieving the security and safety. We have a fire protection system, bulletproof and the blaster-proof, and some partitions. And I will detail in my next slide presentation more about these products. The first part in my presentation is bullet resistance protection. Just to give a briefing concerning the bulletproof, the bullet resistance, there is some classifications. The facade or the windows or the doors, when it is classified to be bulletproof, there is some classifications. The French classifications, they are known according to FB, FB1, FB2, FB3. These are the classification, or what's known also more as bullet resistance class 1, class 2, class 3, until class 7 or class 8. Each class is determined according to the standards, certain requirement for the, depend from the guns or the type of bullets or the distance of shooting, and the bullet and should not pass from side to side. So based on the classification from BR1 till BR6 or BR7, when you go more and more high, you will need more material, more strong component to stop the bullet to pass from side to side. So from Technal product range, we have a wide range of bullet-proof products. We have it in the curtain wall. We are achieving until class 6 as per the documentation, and in some evolution of the product for some jobs in the region in the Middle East, we developed some solution up to class 7, and it was tested also on site, and it was passing the test. We have also doors achieving the class B6, windows, sliders, and the slider is one of the difficult, and I will be showing some videos about some live tests going on a bullet-proof sliders. So for the curtain wall, just to give an idea for our audience, the component of the curtain wall, as we can see on the right bottom corner of the screen, like isometric view showing the glass. For sure, the glass should be also bulletproof according to the classification. And the component of the profiles must be also well designed and engineered and tested to stop the propagation of the bullet from side to side. In the curtain wall, the Geode MXS from Technal, we can achieve until class 5 and 6 by using the armoring, what are in red in the cross section inside the profile. And also in the customized application, we are able to pass to class 7. In doors and windows, here we have more requirement to stop the bullet to pass from side to side. It's not like the fixed panel in curtain wall, because there is a risk that the bullet might pass from the joinery between the sash and the frame. It might pass from the joinery perimeter of the glass. And this is why at the section, we have the armoring, which should be integrated inside the profile to reinforce it and to create a protection barrier for the bullet to pass from side to side. In what we are seeing here on the screen, it's a cross section of a hinge door. You know, in the doors, we have all the accessories like locks, cylinder, even this at the location of the cylinder should be also bulletproof. And when we are offering a solution, it is overall offer solution achieving this requirement. Also in these slides, we can see on the right side, the cross section of the sliders, and please look on it because we will see some videos showing a test on the sliders. We can see the sliders, we have the tracks and we have the sash. One sash might be in the first track, second sash on the inner one. So to provide security for all the zone of the sliders, it's also deriving from well-engineered solution provided by Technal. I'll be running a video showing the test. This is a test on a sliders bulletproof resistance. We can see in the beginning the components. For sure, the fabrication and the assembly will be as per the Technal fabrication document because we will provide a solution. We are getting this completely with all the necessary to be followed. The assembly, we can see here the insertion of the armoring. This is on the sash profile of the slider before the assembly. And for sure, at the miter joint on the corner to achieve the overlap, we can see the fixation of the roller, the gasket, the assembly, the cleats. All the components, they are studied to be rigid and resistant to avoid any propagation of the bullet from side to side. We can see the glazing. As I said, the glass should be also bullet resistance glass. And these videos is recorded in the test, in the lab test for the bullet resistance. The ballistic test is done in Saint-Étienne, in France. The second part we are showing here for sure for the test, they will do the calibration, the type of bullet, the mass of explosive powder on it. So all of this will be controlled also because when you get certification, because when offering solution and we're talking about safety, so the test is monitored and witnessed by third party and they are monitoring all the components. Here we will be seeing the shooting on the standard of the specimen. And the test, the shooting, they will be shooting on the outer frame, on the sash, on the joint. There is also camera to control from inside, from outside. And there is an inspection that nothing should pass from side to side. They'll be shooting on the edge of the perimeter of the glass, on the glass itself. All of this will be recorded, will be checked. And when we get certification, the system is bulletproof. It will provide the security 100%. There is no tolerance we're talking about ballistic resistance or bullet resistance product. And the product offered is certified to pass the class. And with this slider, we are passing until class FB6. And this is offered with the certification and has been used in many projects in the region in the Middle East and in some embassies, jail, palace. The second part, if you're talking about safety in the building, we are hearing a lot about blast resistance requirement, especially from many architects, many consultants at those days in some specific building. The risk when we're talking about blast attack, it might come from different sources. It might come from a certain mass of explosive, which explode the charge at a certain distance from the building. It might be some explosive material. It might be example like heavy truck full of fuel due to some hazard reason was exploded or any attacks or to protect a building. So the explosions, when it will be occurring, there is different criteria to be taken in consideration. The pressure which will be generated from the explosion, and it is impacted by different criteria. The first one is the distance, as we can see in the picture, the distance from the source of the detonation or the explosion of the mass of explosive until the building. It will generate a shock wave, it will be a spheric wave, and it will impact the main facade, and this is what we call it reflected pressure. And the other side of the building will be subject to the over pressure. Based on this, there is studies will be provided on, depend from the type of building. There is some standards providing the pressure generated and providing some classification like ISO 16933. we can see this is different classification according to vehicle bomb explosion, providing pressure, which vary from 30 kPa until 50, 80 and higher. In addition to that, the second criteria in the blast proof, not only the pressure, there is what they call it the impulse, which it will be linked to the pressure related to the time factor about the propagation of the pressure until hurting the facade. And based on the value, according to the classification, because the building can be defined with certain fans and in the function of the building defined by the architect or by the consultant, we can know what are the parameters and what is the distance, and this will be main parameter to study the criteria and to define what are the pressure which might hurt on the facade. And second part, based on the building component on the facade, we can see if there is some material like a glass which are fragile for breakage, or there is some other rigid material like a cladding. It will be also analyzed. And in the example of the picture which we are seeing on the left side, we can see something marked in red. Then above it, this is the wave of the spheric wave hurting the building. Then some part marked in yellow with some red rectangle. The red rectangle, they are the windows, and the yellow one, they are the wall. So in this case, the risk is more on the red zone. And when we go more in height, the impact of the wave pressure will be less. And based on this part, when we have to design something blast proof or blast resistance, we have to take this criteria. And based on the classification, we can study if the component of the building envelope remain at place or it can be projected to outside, and the reduction or not to have any projection to inside as impulse. There is some software used also to make some simulation. We can see on the screen, I'll be running a video on the right side at the bottom. This is like a simulation when we can provide the impact of the pressure on the facade, what will be the ripple effect with the pressure, and the pressure will change from positive to negative. And you can see some videos in the next slides showing the matching with this simulation. I will share with you some tests provided for some jobs. One of them, it was one of the jobs which has been tested for the National Assembly in Kuwait. The requirement of the project after analysis, it was that the facade should sustain the detonation and the wave and the pressure deriving from 55 kg of TNT exploded at 40 meters from the sample. Here we can see on the screen just a sketch showing how to run on the test. They will be the source of the explosions, and the mock-up will be fixed at a certain distance, required distance, and all the equipment and the sensors. And this will be controlled from distance with cameras to record it, and to be very high sensitive camera recording what will happen after the explosions. And it will be repeated in slow motion to show the impact on the facade. So concerning the first requirement, the 55 kg of TNT, it will generate in the range of 29.7 kPa and an impulse of 218 kPa by millisecond. And to give you a briefing about what we'll see on the next slide, I will be running two videos for the mock-up tested under the 55 kg of TNT. And with this pressure, we tested based on this criteria, and when the test was finished, we have run another test on the same mock-up by providing explosion of 100 kg of TNT at a 25 meter from the mock-up. And this was generating 93 kPa and 398 kPa by millisecond. And here you can generate the impact of the high pressure generated by the explosions. These are the mock-up. The first video, as I said, it's recorded on a very high sensitive camera and repeated in very slow motion. You can see now in the lightning, this is the detonation of the explosion. We can start to see the impact of the wave on the sample itself. We can start to see some ripple impact on the glass, and the pressure, it will change from in to out. And the ripple impact, if it is very, very high, in some cases, it might generate some damage in the facade. The studies will be done in non-linear condition. We might get some deformation in the panels. Even some cracks might occur in the glass. Something might be projected to outside. All of this will be classified as passed. Even if there is something detached from the facade, it's supposed to be projected to outside to be classified as passing the test. We can see in the test number 2, on the right side of the screen, Here, the same mock-up have been tested under 100 kg of TNT at a 25 meter, and this is providing 97 kPa. We can see the projection of all the components are going to outside, and this is also classified as passing, and it was passing EXV class 25. And here I'm talking about a facade with a modulation of 52 mm, and for sure we can provide also bigger structure to get more overlap of the glass, and we can go also more and more higher in the pressure. So in this slide, we can see the job which has been, for what we did the test, the upper one is which has been tested. And based on this one, we have also, I can share also with data about another project which has been also studied, but on a pressure 62 kPa, and 470 kPa by millisecond, and the panel, they are almost 10 meter, and the function of this building is not, we know that in the first example, we spoke about very specific function. It's the National Assembly, but here we're talking about a mall in Abu Dhabi, where the requirement is to provide also the facade to be also blast resistance. And based on these requirements, also we provide the solution. Next to the blast resistance, I will be also talking about the third part of safety in the building, the fire. And we have seen in the presentation of Ms. Sandy and Abhishek, who provided their first presentation, they spoke about the testing and about the criteria. Here I can elaborate more from the point of view of system supplier, how we are able to develop solution achieving the fire requirements. In the fire requirement, I will be talking about two parts, and to make it clear for all the audience and who are following us, while talking about the facade, we can get two types of facade concerning the fire requirement. We can get a fire protection facade, that means the full units is fully fire rated facade, and you can get another requirement for the fire propagation from level to level in the building. In the first part here, we are seeing a system. It is a multi-layered fire-rated curtain wall offered by Technal. We can see that there is some component integrated inside the profile, like in the picture on the extreme left side. The infill inside the mullion, they are composed from an aluminum profile surrounded by fire protection material. Because as you know, when the fire is attacking the framing of the facade, the aluminum will melt, and we have to maintain that the glass and the components still retained on place. And this is why, if you are looking on the photos on the extreme right, we can see the component of the main mullion profile. Inside it, we have the cooling profile and the other fire protection material surrounding the sample. We have tested this sample also at the lab of Thomas Berright. It has been tested to provide the classification with the fire acting from inside and the fire acting from outside. And we have used fire-rated glass. And the fire-rated glass will be composed, to give you an idea, it will be composed from a multi-laminated layer with a certain gel in between, which might react. And this is why we are seeing in the photos that some milky color in the glass, because in the mock-up here, we are testing the fire protection for the full components during the fire action in the furnace behind the facade. And we have some continuity of the curtain wall on the right and continuity on the top. So, and here we are getting from the test the fire protection, and we should not get also propagation horizontally left and right and up and down. This has been tested, and as a classifications, when we are testing or we are talking about the components, we have three classification. The first classification is the integrity. That means we are stopping the fire, separating between two parts. And if we're talking about safety in the building, as an example, in the fire, in the staircase, if we have the facade as a curtain wall, we should not get a fire passing from side to side. And if it's passing from the outside to inside the evacuation zone of the staircase, and this will be classified as external fire. If you're talking about case like in a lobby or near a lift zone, we might not get a fire passing from this zone. It will be also as inside. So if we're talking about to protect the people in evacuation, they might be protected from the fire, but if the temperature is very, very high, they might get some burning in their skin, in their face, due to the high temperature. And this is why we're talking also about second criteria, that is what they call it insulation. And this is the letter I used also for classification. And here, we're talking about the classification. We can see that there is EI classifications, and for sure followed by the achieved time. If we are talking about classification only for integrity, it might maybe E 15 minutes or 30 minutes, 45 minutes, 60 minutes, or 90 minutes, or 120. And if it is insulation integrity, it will be EI with the type parameters. And in some classifications, there is something called for radiation. It's noted also with the letter W for the classification. But here for the fire-rated curtain wall, we are talking here about EI classification. And in Technal facade, when tested from outside to inside, we passed beyond 120 minutes. We almost reached 180 minutes, but the classification, it was until 120 minutes. It classified EI 120 for the outside to inside. And from inside to outside, it's classified until 1 hour as 60 minutes. In addition to that, to offer a full range of solutions, it's not only the facade, the curtain wall, we have also a wide range of doors and windows tested also for fire protections. It has been tested also at Thomas Perrite. We can see at the lower parts the testing for the doors. On the picture on the left side, we can see in the furnace 2 doors, and one is open in, one is open out, and it was being tested for 1 hour plus 10%, almost 66 minutes, as we can see on the clock marking next to the sample at the end of the test, and there is no fire passing from side to side. We can see on the second picture on the middle, the testing of integration of double leaf door integrated on fixed panel, which can allow us to create a partitions. And we have it fixed from one side and the second side, it only fixed on top and bottom to provide the simulation of the continuity. And also we have tested for a jumbo size with a picture on the extreme right with a different size of a glass. All have been tested and we passed the classification until EI 60. And these applications for the curtain wall and doors and windows offer for you a full solution in aluminum fenestrations to provide solution achieving the fire protections for curtain wall, doors and windows and fixed. And these doors can be also integrated inside the curtain wall. And these doors has been tested also without threshold to get the criteria of activation as doors. And also we can provide it also as a window doors to get the frame running on the three sides. The second part about the fire protection, it will be the fire protection on the perimeters. That means the fire should not pass from level to level. And here we'll be talking about normal curtain wall. It's not fire-rated curtain wall. This is what we call it non-buried curtain wall. At the perimeter edge, for sure, there is many material used and they are tested and certified as passing the fire requirement. But when they are combined together and the fire will occur, many parameters will occur. We might get some deformation, some deflection of the slab, some expansion in the component of the structure. And in this case, the gap between the facade and the slab might change. And this is where the failure will occur and the fire will pass from level to level. And Technal, I'm proud to say that Technal was one of the first who has worked in the region here in the Middle East. We have worked with our partner, I should thank them, SideRise. They are supplier of a fireboard material. We work together with them to develop the solution to provide a protection at spandrel zone. We can see the impact of the frog lip, which was explained by Abhishek in the first presentation. This is the attack of the fire from the windows or from the glass, which will be broken under the fire. It will pass to outside. And also what we call it, the propagation of the fire between the slab and the curtain wall. And these gaps, depend from the condition of the job. And in the test, we will go to the extreme possible gap which can occur in the building. And here for this one, as being a European brand product Technal, our first test was being conducted in Europe according to European norm, according to EN 1364-04. And here we can see the configuration at the furnace. We can see the mock-up, how it will be installed. The gap was counted until 300 mm between the back of the curtain wall and the slab. We are using also from SideRise the Lama-term CWFS 120 insulation, which will be compressible, and it is dry and it is fixed with certain compressibility between the slab and the curtain wall. We have also the fireboard protection, which will be provided on the back of the curtain wall, and the test was conducted. And with the same type of material from side-rise, we conducted other tests using the presentation at Thomas Berwright Laboratory with their laboratory, where we have tested according to American standard, ASTM E2307 for perimeter protection fire. To give you an idea before seeing the test, how we are integrating this application on the facade, we can see here the facade will be installed first. It can be stick system or it can be prefabricated panel. If it is a stick system, they can install the structure, then they can install from outside to inside the back pan, then the glass from outside. Then they can get the insulation, or it can be also installed from out to inside. Then we can start to provide the fireboard. Here we are seeing spandrel zone composed from two levels. It can be also from a single panel, and the vision will be below that. And here we are protecting only the spandrel zone. And we try to minimize the height for this one to comply with more visibility from the facade, but for sure to secure the fire protection. We are putting two layers, because in the two layers we can put the first layer, then the second layer will overbridging the joint between the panels. Then there is a metal foil to cover it. Then you are providing the Lama-term compressible. It will be retained also with small brackets. It will be compressed until 10% and integrated. It can be fixed on the top, or it can be also installed on the bottom. On the bottom of the slab. And with this arrangement, we have conducted, as I said, the first test in Europe. We can see here on this picture, the mock-up at the beginning of the test. On the picture on the left side, we can see the view from outside for the mock-up. We can see the continuity on the top. We have vision glass, then spandrel zone, then glass at the lower part. And for sure, we can see all the thermocouple to measure the temperature on the outsides. And we can see on the picture on the right side, we can see the top view, and we can see here the Lama-term integrated behind the facade. And in reality, in real case, on the top of this one, you can get the metal sheet extension of the slab. It can give you more protection, but we tested with the severe conditions, bigger gap of 300 mm, and only with the Lama-term material and fireboard. And for sure, all these components will remain stable if the system for the facade is also well integrated for the expansion, for the part to work all together in integrity. So according to EN 1364, it has been tested, and you can see here the picture at the end of the test after 3 hours and 10 minutes. We can see the situations. We can see on the right side the Lama-term remain on place. At one of the thermocoupling, they stop the test when the temperature exceeds ambient temperature plus 180. That means in this case, that is even the fire was in the lower level, we don't get a propagation on the higher level. We can see also the graph and the recording for the time, for the temperature, for the different thermocouples, and even with the record for the movement of the facade, the deflections, the frame, even the frame was popped to outside more than 12 millimeters. The slab was deflecting 25.4 millimeters. With all these criteria, we do not get fire passing from level to level. And this has provided certification that the system is complying with the fire protection at the perimeter at slab level. The second part, here we can see the same typology of the facade, but tested according to American standard, ASTM E2307 for the perimeter. We can see also what was explained by Abhishek and Sandy about the fire action. We can see the room burner, the fire occurring from inside in the lower level of the furnace. And you can see also the fire provided from outside to make the simulation for the frog legs, which can attack the facade from outside. We have tested the same, an XJO, the type which has been tested for EN. And now we are seeing the test according to ASTM. We can see the mock-up prior to the testing in the lab of Thomas Berwright. At the starting of the test, we can see the view from outside. We can see the cavity at the lower part where we have the window burner from outside. We can see the spandrel zone, and we can see the vision glass on the top. And we can see on the picture on the right side, the view on the upper floor from inside, where we can see the fireboard from sideways on the back of Technal facade. We can see the Lamaturn insulations. And the test was conducted for, this is, we can see at 5 minutes, they provide the fire from outside, and we can see the fire acting on the facade from both sides. And you can see the melting of the material component at the window zone and the attack of the fire from outside. And after 3 hours, 10 minutes, we can see the situation of the, we lost some material from the facade from outside, but we don't get any propagations. The fire was not attacking the upper level. From outside and also from inner sides, we got at place also the fire protection at the slab extension was also remain at place. And this has provided also that we are also complying with also American standard used frequently on the region also. And with these 2 types of tests, according to the 2 types of standards, we are able to cover the requirement for American standard and European standards. The last part in my presentation is the force entry resistance, because we're talking about safety. We have seen the bullet resistance, we have seen the blast resistance, we have seen the fire resistance. Here I will share with you some also about the normal product, the force entry. It's also an important criteria to provide the safety for the people inside their buildings. To give you an idea about burglar resistance, so there is some classifications according to the standards. This classifications is known as RC classification. It's classified from RC1 until RC6, and this depends from the type of tools and what will be applied by the people trying to pass through the doors or the windows or the curtain wall. So RC1, we are talking only about to withstand physical forces. RC2 depends from the tools. They can use the small tools like screwdriver, knife. RC3, they can use like crowbar, hammer. RC4, they can use axes, hammer, lever. RC5, more, we can get more expertise in the, they can use some, the sieve, they can use some small electrical tools or something equivalent. And RC6 also more hydraulic tools. So with this type of classification, talking about doors and windows to classify this product according to this one, we have to follow the standards. And for each class, there is a time, because the thief should not, or the robbery should not access inside with a certain time. And RC1, it should be less than 3 minutes. Should not get no direct access. RC2 until 3 minutes. RC3 until 5 minutes. They should access from side to sides. In Technal, we are offering white product in doors. We have until class RC3 in Soleal 55, Soleal 65. In windows, we have Soleal 65, RC2, and they are working now on RC3. Curtain wall, we have also RC2 in curtain wall. In sliders, we have also some slider RC2 and some slider RC3. And slider is one of the most difficult to keep it on place and stable for force entry. So to give you an idea about what we provided, in example, in the doors, we can see on the top part of the screens, the doors, the Soleal doors, classified until RC3. We can see this is a normal doors, and we are offering a certain set of accessories which will be integrated in the profiles to reinforce the locking zone, to reinforce the perimeter of the glass, to reinforce the hinges. In the lower part, we can see the sliders. The sliders, we're talking about a concealed sliders. And by the way, this slider is not only having high resistance, burglar resistance, it's very well classified as high thermally insulated, high acoustics. With all these parameters, the offered product by Technal, it will take in consideration the different requirements to provide the comfort in the building and also the safety. In these slides, I will be showing a video. It was conducted on a slider mock-up displayed in one of the exhibitions, and after the expo has been finished, we have provided one person. He is aware about the component of the lock, and he's trying to break it and to access it from side to side. The product is Lumea, and this has been classified RC3. We can see the other person, and he's using tools like crowbar, screwdrivers, and he's trying to attack the locking zone. And as you know, if he's breaking the lock, he's able to slide the slash and access from side to side. And he is using his tools. He broke the glass using again the crowbar. And as you know, in the classification, the type of tools also they should not produce a lot of noise when they are trying to access from side to side. He's trying to use his hammer, but he's using more his physical forces to crack or to break the frame. He attacked the first side of the door. Then he will be passing to attack the other side. And again, the time is registered because, as I said, he should not be able to access within at least 5 minutes. And here we can see as a slider, so he reached then the frame. He reached the locking point. So, but as it is well designed, and as I said, Technal RMP designing all the product to be tested even before it will be launched to the market. We are offering the solution tested, guaranteed, and you can see he's trying to attack the locking points. Again, he's trying to, because he reaches the locking point, trying to break it, and the selection of the material when we are setting our accessories are all well selected to achieve all the requirements of the standard, stability, safety. He cracked the handle here, but he's still not able to open the sash, and you can see what time it was passing. Trying also to push it to jump the sash from the track. He came to provide the uplifting, and again, as I said, this time is one of the difficult part. You can see here the system is provided with anti-upliftings. He tried to uplift the sash to make it jumping from the roller, also to access. So he tried a different possibility to crack the lock, slide it, and trying to uplift it. And again, he did not succeed because the sliders which we are offering here is rubber resistance, and it's proved by that the guy was able to access it. And then he was feeling fed up, he was tired, and he left the mock-up. So that's it from my side. I should thank you for your follow-up. And here maybe I can return back the mic to Arvind.
Thank you so much, Sami, for your wonderful presentation.
Thank you, Arvind.
You had gone through quite a nice detailed set of information, right from standards. You talked about bulletproof, blast-proof, fire-rated systems, and also you talked about burglary, anti-burglary products as well. And on that note, I did a small poll to understand how important is anti-burglary products, and I was surprised to see more than 60% of them believe that they need to have some good anti-burglary systems, especially now we have
those days, yes. True.
So many townhouses, and people can just easily access each other's house quite easily. But thank you very much, Sami, for your wonderful, wonderful presentation. I now take the chance to invite back our panel onto the screen. I'm going to stop sharing my screen. We had today quite a variety of presentation from testing to standards to compliance steps. And we talked about various products and solutions on life safety. I want to now invite Isha to take on some questions, because I see there are more than 50 questions which have come up both on the chats and the Q&A section. So I will leave Isha to guide us with some good questions. And we are overshot by about 10 minutes. So we will take as many quick questions as possible for our panel today. Over to you, Isha.
To unmute your mic.
Okay. Thank you, Arvind. Thank you, Sami. Thank you, Sandy and Abhishek. It was really an informative session. We have a lot of questions pouring in, and I'll start with a very basic one, which I think all of us have in mind. What would be the difference between EN standards for testing and ASTM ones? Would you comment on their performance, or do you consider either one of them more stringent than the other? Open to Sandy.
Yeah, hi Isha. EN standards and ASTM standards, it depends. Basically, there are EN standards for everything and ASTM standards for almost everything as well. So for physical curtain wall tests, for water leakage, structural load, for building movement, all these tests can be either ASTM or EN. And the same applies to fire tests. So ASTM are more common here in the UAE, but also EN tests are just as comparable to them. So it depends on the test standard and what exactly you are trying to compare. It's a very vast question, you know, that has many probabilities and options.
I will add a little bit to help Sandy there. And this is a question that we get asked a lot as a laboratory. Obviously, we've got people on both sides of the spectrum, you know, people who come to us and say, can you tell me the easier of the two, obviously. And then there are people who come and ask, which is the tougher of the two? We would like to enforce that. And I think it's very important to understand three aspects of this. You know, one is to know, and a lot of people know this, that EN standards, the European standards, are evolved by the European member states voting in for what they all think is important and critical in their geography, in their climatic zones, as well as in the construction type prevalent in those regions. So a lot of times, many European countries have a lot of wood-based structures. So it is the perspective that European standards come from. American standards again, and ASTM is slightly different because ASTM also involves a lot of people from worldwide. It's a very open system to develop a standard, but it is American flavored, which means that not only does it bring the flavor of construction type and environment, etc., but it also brings forward the legal construct in which North American or American construction industry work, which is very different as others. So the third thing, which is very important for you to choose what is a good standard, is to understand the geography that you are in, the jurisdiction that you are in, which has layers of government's minimum requirement, which has layers of what is the climatic environmental zone that we are in, and understanding your project. The project that you are involved in may be unique, and in certain areas, a certain test is better positioned to give you the data points. As an example, the large-scale fire propagation test, NFPA 285, versus the British standard, the BS 8414. And it is a perennial debate around the world that, oh, is this more stringent? Is that more stringent? And I think people who comprehend the test, they should, would be able to arrive at saying that, well, for my project, I have a scenario which has, let's say, reflection coming in, and I need an L-shaped test set up for the BS 8414. Sure, let me get data from this test method. So no straight answers, but delving deeper into understanding the test methods can give you a very good way to select.
Maybe I can add small points. For sure, it was clear. It's an open question because talking about comparison between the two standards. But from point of view of the system supplier to offer solution for the end users or for the architect consultant, we are offering a system tested under both standards. If you have been tested under ASTM or under EN, as being international system covering the 5 continents, we have to comply with both with the different standard and the nature used of the ASTM in our region here. But in Europe, EN it's also well demanded. And for sure, with the facilities which I have it also in the region with Thomas Perrite, also we can test both standards. And for also as an answer, we can test both standards.
All right. Just to put it more empirically, for instance, if it is a water penetration, water infiltration test, okay, it is. I don't know if it is correct or not, but largely the perception is if the mock-up is tested as per ASTM, it gives a better performance than the if it is tested as per EN norms. Is it correct, or if it is a myth, I would like you to refute it.
Well, the two standards, they do not work exactly the same. Basically, in ASTM, you have one pressure only that you run for 15 minutes, okay? But in CWCT or in EN tests, you increase the pressure, you keep increasing, and then you have a threshold at which you give a rating to a system. So the two approaches are totally different. One is a classification approach, and then you see if there is a similar classification in the project. And the other one is just simply a test to a certain criteria with a pass-fail. It's not a classification result. So they are comparable, but they are not exactly the same.
The same, yeah. True.
They're two different approaches.
Okay.
Yeah, the criteria, the time, the pressure, the step, if you're talking about the water tightness. Air tightness, they are also comparable between American standard and EN. They are comparable, but they are not exactly the same.
All right, all right. So we have a lot of individual questions directed to the individual panelists. I suggest we can send them across to you and you can answer. But looking at the larger scale, we will take a couple of more questions before we run out of time. It's already 6 o'clock in India. So talking about the blast resistance test that you talked about in your presentation, it was both the tests were from outside. So we have a question which asks, is there any test or any method by which we can see the integrity of a curtain wall if the blast is inside?
This depends on the definition of inside, because here we spoke about the charge or the explosive which will occur at a certain distance from the building. This is what they call it the vehicle bomb classification. But for sure, if it's about something inside, like any car, it's coming and crossing the safety of the security of the building and going, to example, to the parking, and the blast occur in the basement or some part, the structure of the building by itself here, it will be impacted. And here it's another case. It will come to the structure itself if it is designed to resist this, because the structure, the concrete or the steel structure of the building is holding the facade. So definition for the blast from inside is also another wide field for discussion and for criteria. And the impact of this, it might impact on the floor wall, it will occur, and for sure it will impact the full stability of the building. So this is why they will take the distance from the building, and the accessible zone also, and the type of the facade in the building envelope. Maybe you don't need to design your full building as blast. Maybe some facade, they are protected. They are not facing the highway where the people they can access with the car. Because at the end, also the cost should take it in consideration when you have to provide this type of things to keep equilibrium of the cost for the developer or for the owner.
All right. That's interesting. Also, if the blast is from inside, people are already dead. So
we hope so. No, at the end, the objective is to keep the people safe. We hope that safety will be taken also in the security that they not. This is why they put more security people on the gate or on the access inside the building.
Correct. So
now at those days, I can classify. I can also. There is also more evolution in the development of the explosive materials. For example, there is the C4. Now the person carry 4 kg of C4. It's equivalent of I don't know how many kg of TNT. So he cannot go in a vest and he can go inside it. So this is where there is more maybe should be more. There is more control on the access in the building based on their type. If there is more crowd, more people, and we have seen an example of a mall where the requirement they are to protect the people, and they put more scanner or detector to control what is going inside the building.
Correct. That's the important point. Okay, so on the methods of testing, we have another question. Mr. Michael Barry is asking, with dynamic aero testing, how do you know what speed or pressure the motor needs to generate? Is it from the deflection of the facade or pressure against the facade?
Okay. Earlier, before in the old standard, you used to calibrate the speed of the airplane engine depending on the deflection of the facade. So for example, if I want to generate a speed of the motor equivalent to 300 Pascal, I generate a static pressure with the test chamber of 300 Pascal, and I measure the deflection. Later on, I put this off and I put my airplane engine on, and then I measure the deflection. I keep increasing the airplane engine speed until I reach the same deflection. So now, with the new standard, there is a different way to evaluate. It is based on the speed. So you should have a speed controller, and then you measure the airspeed at quarter points in front of the propeller. So you do not only depend on the deflection at the level of the facade itself, you have to measure at quarters in front of the airplane engine itself, in front of the propeller. And this is how you set certain speeds together with certain pressures. So it used to be deflection only, but now it has changed.
All right. I hope, Michael, this answers your question. All
Isha,
right.
I see a very interesting question, and I think this is a very important question for today, and this is directed to both Sandy and Abhishek. This is from Angelos, and he's asking, hey guys, how is it possible to perform testing while there are limitations in transport of samples, limitation of travel to access factories and sites for engineers? How do you do testing in a lockdown situation? So I thought it was a nice question to, sorry to put you on the spot.
Let me try and answer. I mean, at the outset, yes, in the UAE, unlike India and many other countries, we have a less restrictive lockdown. So as a laboratory, we are open and we are functioning. We've also seen that material movement is happening, even though people movement is happening. I was shared, I think Sandy and I were talking a few days ago that between the border of UAE and Saudi Arabia, you know, the rule that has been set in place is that the trailer, which is carrying any goods, whether it is construction material or food or anything, goes up to the border, and the trailer delinks, and the driver goes back, and another trailer's driver picks up the cargo in Saudi Arabia and moves it. So from what we've seen, that material movement has been happening. So goods have been moving from one place to another. We are in the process of fine-tuning a kind of an online live video that we can extend to our customers who want to witness the tests. And it was relatively easy to get a live video on, but we are actually being a little more ambitious, and we want to try and also give the control of, you know, pan, zoom, tilt to the person witnessing the test somewhere else, which is coming up as a bit of a technology snag in terms of privacy, etc., etc. As well as the fact that we have always had a layer that we have local installers and subcontractors who are available kind of for any of our clients who want to install the materials in our lab via someone else under somebody else's guidance. And I think technology has enabled a lot of this. So we have been receiving samples. We received, I think, about 10, 15 fire-rated doors from the UK last week, despite lockdown. So things have been in motion, of course, at a slower rate. I hope that kind of answers the question, but yeah, beyond that, it's difficult to answer.
So to summarize, if the material movement is not there, we cannot do the test. Right?
Yeah. Then it's just theoretical work, you know, which we can do simulations, software and all of that.
Yeah. So coming to the theoretical simulation, we have a question where they're asking for, especially for blast resistance and bulletproofing. Is it possible to just theoretically define whether the system would be able to pass a certain standard, like, you know, the classification of BR6 or BR7, or likewise in the blast resistance?
Concerning the simulation, yes, as I said, there is some studies can be provided, but as I said, in non-linear methods, because we can allow some deformations, we can take the value of the pressure, and this is why we have to put some reinforcement maybe inside the section. We can study also the bite of the glass. This is where we can go with wider module, maybe not 52, maybe module 90. We can add some bonding of the glass. All of this should be taken in consideration. And the most important part is the reaction at the bracket support, where we can connect the structure of the facade or the curtain wall to the slab. And this is important. In some cases, some bracket might be installed during the casting of the concrete to retain it, to resist for high reaction. And this is function of the requirement if the specification call that the facade still attached to the building, or if they're allowing that after the blast, if there is any detachment, in this case, they have to repair the full facade, because in all cases, some damage will occur in the facade, because the objective is to protect the people inside the building. This was the main topic. Next to this one, to minimize the damage. So based on the requirement, because the pressure is very, very high, the component will be more. And this is in the simulation. We can take the different scenario. Simulation with, we can see there is high risk, less risk, medium risk. This depends from the requirement. In some projects, which we did, even for the bracket, they are providing a bracket like a U, and it is on the fixed from the top to the slab until the bottom. They were ready the slab from side to side to retain the bracket. It was a bracket 60 centimeter by 60, because it was a huge reaction. Some they are cast during the concrete, so it depends from case to case. Yeah, but it can be simulated. Even in some simulation, also they can study when the wave or the pressure is hurting the facade. Maybe the first layer of a glass will break, then we can do the second one. Even there is some dynamic simulation can be provided, how the infill is acting inside the structure. Yeah, this can be provided.
Okay. So I think we can take one or two more questions. Arvind, what do you think? It's very interesting. I mean,
I know you're flooding with questions. It's cost again another 60. Just can we take one last question, and then we can definitely reach out to them one by one post the webinar.
Okay. So if it is the last question, I would, it's again on the fire testing. If there is a requirement of a curtain wall system, the spandrel has to be fireproof or the smoke proof. When the spandrel should be fireproof, then does the facade wool mullions and transims also need to be fireproof for a certain 120 minutes or 60 minutes, or just the spandrel proofing is enough?
Here,
I'll let Sami go ahead, then I'll add in.
Concerning the type of facade, when you're talking about fireproof curtain wall, it is completely overall fireproof, that the integrity and insulation, the other classification, the fireproof side to side. Then the other component, we can find the mullion with their infill inside it. We can find the glass as a fireproof glass. We can find the spandrel. While talking about only the spandrel zone, the spandrel, as you know, the spandrel, it's a dummy zone. So we are providing the protection with silence fireboard, as example, on the back with the vapor barrier, with the metal sheet. All of this will be on the inner side. If the vision below it is with a normal glass, the glass might break under the fire. And this we can see what was shown by Abhishek in the test, the wind of fire, the fire coming from outside. And this fire might attack the glass from outside and damage the glass of the spandrel. But the height of the spandrel secured by the components of the tray, the protection, the fire insulation, and the fireboard will maintain to, this is what they call it C+D in the standards, in the French standard for the fire protection, the height of the spandrel. And in the height of the spandrel, this is where we can define the height to block the fire not to pass from level to level. But the other component will be a normal, non-bearing curtain wall, normal curtain wall with normal glass for the vision, not for the spandrel. This is from the point of view of the system. And if Abhishek wants to add anything concerning the testing point of view. there is no test to test a facade for the fire rated only with a spandrel zone required as a fire rated.
Okay, Abhishek, you want to add something?
Sure, sure. Well, at the outset, everybody should be on the same page that when we are talking of fire resistance, we are talking of being able to compartmentalize a fire. And fire resistance as a property should then hence be understood as not a property of a section of a system or any material of a system, but as a system as a whole, as complete. You could have just as an example, you could have a fire rated glass, okay? Glass that can resist fire for 3 hours. But if the glass cannot stand alone,
True.
and if the framing mechanism and the system that is used to build a fire rated partition using glass as a system, they do not connect with each other, they do not help each other as a system, the system will fail. So you will have a glass which is fire rated, but the brackets are wrong, or there are so many aspects related to it. So, this same example goes on for just about every element that we can talk about for fire resistance, whether they're fire rated doors or ceilings. And hence, we can never have a component or a section fire rated alone. And then it cannot go with everything which may not be fire rated and expect that it is Midas touch. You get one component and everything gets fire rated. It doesn't work like that.
Right.
And this is why there is two types of standards. There is one standard for the fire rated curtain globally, and there is standards for the protection as a perimeters, horizontal.
Yeah.
So this is based on from the source of the standards, we can develop the solution and we can propose a product and we can test it.
Okay. I think this the situation is sometimes in the specification it's only mentioned, floor to floor fire protection, fire barrier should be there. So probably that is the question, if I'm not.
And I will add one important point. Maybe we did not talk about it. We are talking more about the component of the facade, and also the slab behind the curtain should be also fired if they are asking for classification for 2 hours or 2 hours. The concrete behind it should be also for the same rate, because this is where we are fixing the mechanical fixation for the facade. So when this is a good clarification for all people writing specifications. So this is, they have to get the matching of the requirement. They have to specify the facade and specify the other components. And they cannot specify, on example, as a spandrel without the other parts. So it should be well analyzed when specifying the requirement for the building. And also for the, if I'm talking about a zone like a staircase to evacuate the building from the people, so we can say the time required to evacuate. And I will not specify 3 hours for a facade if the building is not very, very high, and I'm able to evacuate the building by 1 hour. So based on the function inside the building, there is some parameter will be taken in consideration to define the requirement.
All right. Okay, then, so let's take all the other questions on email. We'll send the questions individually to you all, and whenever you find time during the weekend or whenever you can answer to them at your leisure, and we'll send the answers to the respective questioners. So thank you once again. It was really interesting, very informative, and need of the hour, safety. So over to you, Arvind.
Thank you, Isha, for moderating the questions. Once again, a big thank you to all our panelists, Sandy, Abhishek, Sami, for taking our time to walk us through what I call a need of the hour, because we're all at home, we're all here, and I think on 2 levels you have touched today. One is of being ourselves aware of what are small things which we can take care of today in terms of safety, but also in terms of regulations and tests, and what are the other requirements which we can do to further safeguard our buildings and our workspaces, and probably the spaces where we all live and work in one go. With that, I would like to quickly inform you about our next webinar. Now, this is probably our season finale. We started this season, we're talking about digitalization, we talked about sustainability, we talked about facades for high rises, and today we covered life safety. And as a grand finale, we want to talk about how will facades evolve post-COVID-19 from a design perspective and also from an economic situation perspective. So for the first time, we will have a banker on a facade webinar. We have the Director of Economics from Citibank from Frankfurt. He will join us. He will walk us through some overview about how the situation is going to evolve, the opportunities more than the challenges which are arriving at post-COVID. We have with us also a legendary facade consultant from India, Mr. Mahesh Armugam, Region Director for Meinhardt in South Asia. And we also have our President, Henry Gomez from Hydro, and our VP Asia, Jean-Marc, and our Managing Director, Sam Robinson, will join us on 13th. The timing is different. It's 1 p.m. There's a registration link is already open. You can also scan your QR code to register for this event. So please do join. It's going to be a very interesting session from a both economic as well as from the industry perspective. So I look forward to welcoming you on 13th May, so Wednesday at 1 p.m. UAE time. All these recordings will be available on YouTube. So we have a YouTube channel dedicated for all our webinars. It's called YouTube Technal Live, and you can again take a quick scan of this QR. It will directly lead you to the web page. And your feedback is extremely important to us. We want to do more and more conversational, educational sessions. So please take some time out. As soon as you log out of today's call, you'll be redirected to the survey link. Please give us your feedback. That's going to be really, really helpful for us to do more and more such interesting sessions in the future. So once again, I will see you on 13th May. And before we sign off, I would like to have just one word from all our panelists. Just a closing note. I will start with Sandy, and then Abhishek, and then Sami and Isha.
Thank you. I encourage everybody, to work very hard and review things once, twice, and 3 times, and try to, collaborate together and come forward with solutions in order to pass these difficult times. And thank you very much, Arvind. Thank you, Technal, for inviting us.
Thank you, Sandy.
I'd like to thank Arvind and the complete Technal team for having us here. It's been quite an interesting session, and compliance is a very, very vast field and has many layers related to comprehension of standards, comprehension of legal requirements, comprehension of functional requirements, and how they can overlay onto products and systems. And I know that there have been quite a few questions which, as Isha would be pointing them to us, I would take them all offline on emails or probably even phone calls. But this has been a great session. Thank you so much for having us, and thank you so much to each one of you for listening us.
Thank you, Abhishek. Sami?
And also from my side, I would thank you, Sandy and Abhishek, for joining in the panel to present this interesting subject. It's a high topic at those days. It's a good experience at personal level, because usually we have been used to make presentation at the stage and talking to audience directly facing us. Now, this is a change after COVID situation, how the situation is evolving and changing. It's a good experience and really good. Thanks to all our audience and followers. And I invite all of them to follow us in the event of 13th May, because it will be also interesting like today's subject. And thank you.
Thank you, Sami. Isha?
Well, I thank you again, the panelists. It was again interesting. We've spoken about it, but yes, I would like to thank the audience. You've been very patient and very interested. And don't worry, all your questions will be answered. We'll send them across to you, and we look forward to hosting you again for our finale on the 13th. Please join us there. Thanks again.
Thank you all. Thank you, everybody. Have a wonderful evening. Take care.
Thank you.
Thank
Bye.
you. Bye.
Okay, thank you very much. Bye, guys.
Bye, guys. Bye-bye.
Bye-bye. Thank you. Bye-bye.